This course module will familiarize you with the applications and application areas of gas analysis. Let's get started with combustion processes, the most important area of applications for continuous gas analysis. Combustion processes can be found in many different industrial areas like the generation of heat and electricity, process steam production, municipal and hazardous waste incineration, surface treatment, for example in annealing processes, melting processes as used in metal or glass production, roasting process, for example iron ore roasting, sintering, steel production, and cement production, to name only the most important. Combustion processes are the major sources of air pollution. Fossil fuels like natural gas, coal or oil, but also waste, for instance vehicles' tears, and biomass represent the major basis of energy sources. Combustion of these components leads to gaseous pollutants. The outlet of pollutants containing exhaust gas into the atmosphere is called emission. The measurement of pollutants is called emission monitoring. Due to the harmful effect on the environment and the global warming potential of these components, tremendous effort is made to reduce the pollutants in exhaust gases by combustion optimization and exhaust gas treatment. What are the major components in exhaust gas we want to measure? Carbon dioxide, water, and nitrogen. In reality, combustion is incomplete. This leads also to carbon monoxide, hydrocarbons, and excess oxygen. Sulfur, which is present in many fuels, plus nitrogen from air, will form sulfur dioxide and nitrogen oxides. Especially in waste incineration, hydrogen chloride and hydrogen fluoride are found. Mercury and particulates are also emitted. Next, we will see the typical measuring points, which are also called sampling points, where measurement takes place. A coal-fired power plant can be used as a representative example of all kinds of combustion processes. This is independent of the purpose of energy production or fuels used. Combustion efficiency. Ideal combustion needs the right amount of oxygen. The oxygen value can be measured with a paramagnetic oxygen analyzer like Magnos 206. Efficiency of DNOx process. Nitrogen oxide and nitrogen dioxide are a major cause for environmental damage. These components are removed by injection of ammonia. The injection of ammonia is regulated via the NO/NO2 concentration in the exhaust gas. The efficiency of this process is controlled by monitoring the outlet for excess ammonia. Analyzers used are infrared photometer for NO, or alternatively ultraviolet photometer Li for NO and NO2, and laser analyzer for NH3 measurement. Electrostatic precipitator. The typical measuring component in this part of the process is carbon monoxide. Since CO is a flammable gas, this measurement represents a safety measurement to avoid explosions. The suitable analyzer is the URAS 26 photometer. Efficiency of the DSOx process, desulfurization. The efficiency of the flue gas desulfurization is monitored by measurement of SO2 with URAS 26. Analyzers that are used in emission monitoring have to accomplish legal requirements depending on local legislation. This requires approvals or certificates issued by testing institutes like the German TÜV or other certification bodies worldwide. Both analyzer series, Advanced Optima as well as EasyLine, are certified according to international standards, as required by the European Union and US EPA. These analyzers can be applied in emission monitoring worldwide. Typical measuring components for emissions are CO, NO, SO2, and O2. Another application that is not linked to emission monitoring or process control can be found in power production, the leakage monitoring of hydrogen in a cooling system of turbo generators. In order to increase efficiency of turbo generators, it is necessary to cool them. Hydrogen is used due to its higher thermal conductivity compared to air to make it more effective. However, hydrogen is potentially explosive in mixtures with air. Caldos 27 is used to monitor the cooling gas continuously. This is called a safety measurement. We have already talked about the measuring points in process control and emission monitoring in a power plant. These measuring points can also be found in waste incineration plants. Combustion control, CO measures, and oxygen and protection of electrostatic precipitator. Process control of scrubber 1. HCl removal and SO2 removal with URAS 26. Monitoring the ammonia dosing to the DeNOx process. Activated charcoal filter to remove dioxins and hydrocarbons. Safety measurement to monitor random occurrence of partial self-ignition of the activated charcoal. Emissions monitoring. According to local legislation with ACF-NT, for all components CO, CO2, NOx, SO2, HCl, and HF, plus multi-FID 14, for total hydrocarbon measurement. Cement is the basic ingredient in concrete, which is the key building block for construction industry. Cement is typically made from limestone and clay. These raw materials are extracted from a quarry and crushed to a very fine powder. This raw material is called the kiln feed and is heated in a rotary kiln to temperatures of about 1400 degrees C to 1500 degrees C. The material formed in the kiln is described as clinker. Cement production is one of the world's most energy-intensive industries. Let's have a look at the important sampling points in a cement plant. Measuring point 1. Coal silo. A major threat in coal silos is the random occurrence of smoldering. This leads to elevated CO concentration with the danger of explosion and toxic impact. The CO measurement is done with URAS 26. Measuring point 2. Calciner. CO2 and O2 values are measured for optimizing and controlling the combustion for lower fuel consumption. CO is measured with URAS 26 and O2 with Magnos 27. Measuring point 3. Electrostatic filter. To protect the electrostatic filter from explosions, CO is measured as well as oxygen. Measuring point 4. Stack continuous emissions monitoring. Depending on international requirements for emissions monitoring, a number of gas components have to be measured continuously. The components are CO, NOx, SO2, and depending on the fuel used. Additionally, HCl. HF, and total organic carbon. Measurement at the kiln gas inlet is one of the most crucial measuring tasks. As you can imagine, the high dust load and the high temperatures are very challenging requirements for the gas sample handling system, continuous gas analysis, and sample handling. The analyzers, the gas cooler, and the sample gas feed unit are integrated in a standard system that is called ACX. The gas sampling probe and the retractor system that moves the probe in and out the rotary kiln are called the SCK. This system assures validation of clinker quality, minimization of fuel costs, and optimization of combustion control. Beyond emissions monitoring, many other applications can be found in chemistry and petrochemistry. One of the most important applications in chemical industry is the production of chlorine with the chlor-alkali electrolysis process. Components of interest: hydrogen and chlorine. Major chemicals mainly used in fertilizer manufacturing are made in the Haber-Bosch process, ammonia production, and the Ostwald process, nitric acid production. More applications can be found in sulfuric acid production, ethylene production in cracking process, recycling gas, hydrogen in hydrocarbons, and air separation and hydrogen production. In all of these applications, continuous gas analysis is required for process control, quality assurance, and safety measurement. In iron and steel production, the major operations related to gas analysis are coke production, sinter process, iron production, especially top gas analysis, steel production, and steel refining. What have you learned from this module? Gas analyzers have been installed in almost every industry throughout the world. The application for gas analysis goes far beyond emission monitoring. Process measurements are successfully installed in many industries, like chemical, petrochemical industry, power plants, iron and steel, or cement production and waste incinerators.